Hello and welcome back to my class, my beloved kids. I hope you are all doing well. So today we are going to continue with scientific notation. Yesterday we spoke about the positive powers of 10, which we've used to write very big or very large numbers. We had an example of the distance from Earth to Sun as an example. Today we are going to speak about scientific notation with negative powers of 10. Before that, let's solve together the yesterday's homework. You are given these numbers here, and I wanted you to write them in a scientific notation. So you have 58,927, and we wanted to write it as a scientific notation. So we have the decimal point that we are going to move until the place between 5 and 8. So we will have 5.8927, and this number now is my number here is between 1 and 10. That's good. Now I'm going to count how many places I moved the decimal point. That is 1, 2, 3, and 4. So it will be times 10 to the power of 4. Alright, the same for the other numbers. 6.73 times 10 to the power of 6. This is 9.77 times 10 to the power of 22, which is a huge number actually. Look, this is a number of atoms. So instead of writing this huge number, we're just going to write this small number. That's why we use the scientific notation. Here we have in 2, we have 1.304 times 10 to the power of 9. Here we have 1.33 times 10 to the power of 4. And 3.84 times 10 to the power of 5. In the second part here, you are going to do the inverse. So you are given the scientific notation, and I wanted you to find the standard notation. It's very easy, so you are going to do the inverse. So you are going to move your decimal dot to the right. So 4 times 10 to the power of 5. Alright, so this 5 indicates that I'm going to move my decimal point 5 places to the right. So first I'll write my 4 here, and I'll start moving the decimal point 1, 2, 3, 4, 5. At each step I will add a 0. So in total I have 400,000, which is equal to this number in standard form. In number 8, the number is 1,849,900,000, which is this number. You have in number 9 6,410. In number 10 you have 84,560,000. In 11 you have 100,000. Finally, this huge number, I believe it's 90 billion. So compare your answers with these and see if you have given the right answer or not. Alright, let's move to our new class. So we're going to speak about negative powers of 10 today, and it is again scientific notation, but in this time we're going to use it to write very small numbers. So let's first notice how the decimal point moves in the list below. I have this number as an example, 1.345 times 10 to the power of 0. Okay, it is equal to 1.345 in the standard notation. I'm not going to move my decimal point because it's 10 to the power of 0. Now here, 1.345 times 10 to the power of 1 in scientific notation. So I'm going to move the decimal point 1 place to the right because I have here power of 1. So this number is equivalent to 13.45. The same thing for 10 to the power of 2, where I can move the decimal point 2 places from here to here. So it will be 134.5. What about moving the decimal point 3 places? Then my 10 should be into the power of 3. Now let's go to the other direction, moving it to the left. Okay, 1.345 times 10 to the power of 0. Here I have a power of 0, so nothing is moved, nothing is changed, so I will have the same number. Why also? Because 10 to the power of 0 is equal to 1. That's it, no changes happen. Now the second number is 1.345 times 10 to the power of minus 1. In this time, I'm going to move the decimal point to the left. So it will be 0.1345. If I have 10 to the power of minus 2, it will be moved 2 decimal places to the left. So it will be 1, 2. Here is my decimal point. So it will be 0.01345. Now, if I want to move my decimal point 3 decimal places to the left, then my power should be minus 3. So comparing these operations here with these operations of positive power on the left, what can we see? When we are using a positive power, I'm moving the decimal point to the left with the number that is expressed in my power. Here 0, I did not move it. Here 1, I moved it once. Here 2, I moved it twice. 3, moved it 3 times. Whereas when we are using the negative powers, we are going to use it as motion to the left. So here to the minus of 1, so I'm going to send it to the left with 1 place. So it will be 0.1345. The same thing here, 10 to the power of minus 3. It is in negative power, so I will move it 3 decimal places to the left. Now, writing a number in a scientific notation, when the number is between 0 and 1, use a negative exponent. For example, I have this number which is very small, 0.0783. It is in standard notation. If I want to write it as a scientific notation, okay, I need to move my decimal point to the right. Why? Because this number is already smaller than 1. I should make it between 1 and 10, remember. So to make it between 1 and 10, I will make it bigger by moving my decimal point 2 places. Now, the result is 7.83. Look at this number. Is it between 1 and 10? Then the first step is correct. The next step is to find the power of 10. Since I moved to the right, then my power should be negative. How much? 2 places, so minus 2. The decimal point moves 2 places to the right. Let's have an example. The average size of an atom is about 0.000000003 centimeter across. Wow, very small number. Now, instead of writing all of these zeros like this, we need to find the scientific notation for this number. So, first, we need to write this number as a number between 1 and 10. Here I'm going to use 3, so I'm going to move my decimal point here until I get 3. So we place the decimal point at 3.0. Now this number is between 1 and 10. First step is correct. Now, second step, I will count how many times I moved my decimal point. So here I moved it 8 decimal places. So the power of 10 here will be 8. Since I moved it to the right, then my decimal dot that moved to the right gives me a negative power. So it will be 10 to the power of minus 8. So at the end, my number is 3.0 times 10 to the power of minus 8. Look, it says since this huge number is less than 1, it's very small, less than 1, then here we need to move the decimal point to the right with a negative exponent of 10. Alright, so let's make a summary. If you have a large number that is greater than 10, means you are going to move the decimal point to the left and your power of 10 will be positive. But in this case, if your number in standard form is less than 1, you need to move the decimal point not to the left but to the right. And the power of 10 in this case will be negative instead of positive. That's the only difference. Okay, let's have a few examples. 0.00000829. This is in standard form. I need to write it in a scientific form. Very easy. First, the number is less than 1, right? So I need to move my decimal point to the right, and the power of my 10 will be negative. So how many places should I move the decimal point? I will move it until the place between 8 and 2. Why? Because I need to have a number here that is between 1 and 10. Is 8.29 between 1 and 10? Yes. So the first step is correct. Now times 10 to the power of minus what? Minus how many times I moved my decimal point. In this case I moved it 5 places, so my power will be minus 5. Let's look at this number. It is 0.302 less than 1, so my decimal point will be moved to the right until 3.02, that is number between 1 and 10, times 10 to the power of minus 7, which is how many times I moved my decimal point. Example 6. A typical red blood cell in human blood has a diameter of approximately 0.000007 meter. Very small. That's the blood cell. I need to write this number in scientific notation. So my number is less than 1. The same thing, I'm going to move my decimal point after the 7. Is 7 between 1 and 10? Yes, correct. Now 7 times 10 to the power of minus, because I moved my decimal point to the right. How many places? 6 places, so my power will be minus 6. So the red blood cell has a diameter of 7 times 10 to the power of minus 6 meter. Alright, now let's study the inverse case when I have the scientific notation that has a negative power of 10 and I need to write it in standard notation. Very easy. I have this number. It is platelet dimension that has a diameter of approximately 2.33 times 10 to the power of minus 6. Again, this is a very small number. I really need to write this number in standard form, means in a single decimal number. So what I'm going to do, in this case, I'm going to move my decimal point back to the left. How many places? With 6 places. How can I know it's 6? By looking to the power of my 10 here. So 6 places, I will write the number 233. Now where is my decimal point? It is between 2 and 3. Now starting from here, I will move it 6 places to the left. Then what is the result? It's 0.0000233. Alright, then this number is the standard notation for the number 2.33 times 10 to the power of minus 6. Alright? Now, let's have some deep thinking. Look at this number, 0.9 times 10 to the power of minus 5. Is this number written in a scientific notation or not? What did we say about this scientific notation? We said that it's a multiple of two numbers. The first one should be a number between what? 1 and 10. Now, is 0.9 between 1 and 10? No. So this form here is, or this notation is not a scientific notation, it's wrong. I need to have this number, remember, between 1 and 10. Alright? So, what I'm going to do, I'm going to move my decimal point one place to the right, okay, that gives me 9, okay. Is 9 between 1 and 10? Yes, then this is correct. Now be careful, since I moved it, I need to change the power. I will increase the power by -1. So -5 -1, which is -6. So this is the correct scientific notation for this number. Remember, first number should be between 1 and 10. Alright, number 8. Which number is larger? 10 to the power of -3 or 3 times 10 to the power of -2? What do you say about these two numbers? Now look at this number. 3 times 10 to the power of -2, it is what? It is 0.03. Whereas this number, it's 0.002. So this one is smaller than this one. So in negative power, the smaller the power is, the smaller the number is. -3, we know that it is less than -2. Remember how to compare integers, because -3 is far from 0 than -2. So this number is smaller. This one is the largest. So 3 times 10 to the power of -2 is the larger number, is the greater. Alright? Few examples to write scientific notation of negative power of 10 into standard notation. I have here a number which is 1.045 times 10 to the power of -6. Okay, I need to write it in standard notation. Here the power is -6, so my decimal point here will be moved to the left. How many times? 6 times. So I will move it 1, 2, 3, 4, 5, 6 times. I will put the dot 0.0 . Then this is the standard notation for this number. For the number 9.9 times 10 to the power of -5, I will move my decimal point 5 places to the left, means I will add 4 zeros and a dot and a 0, and that's what I have here. Now 11. Jeremy measured the length of an ant as 1 times 10 to the power of -2 meter. Write this length in standard notation. Easy. My power is -2, so to convert this number to standard notation, I need to move the decimal point to the left. How many places? 2 places. So it will be 1, 2, 1, 2. So 0.01. This is the standard notation for my number here. Alright, class dismissed. I hope you are going to enjoy your days as usual. Stay comfortable, sleep tight, eat well, save yourselves, use sanitizers, do not move out of the home. Hopefully things are going to be good and we are going to meet again in the school. Take care and bye. See you tomorrow.